Welcome back to our series on basic aircraft maintenance practices on the Learjet. In this video, we're focusing on a crucial sensor that helps pilots understand the aircraft's proximity to a stall, the Angle of Attack Vane. Before we dive into the vane itself, let's quickly define Angle of Attack, or AOA. It's the angle between the chord line of the aircraft's wing, an imaginary straight line from the leading edge to the trailing edge, and the relative wind, which is the direction of the airflow as the aircraft moves through the air. Understanding AOA is important because it directly affects how much lift the wing generates. As the AOA increases, lift generally increases too, but only up to a critical point. Now, let's look at the Angle of Attack Vane. On the Learjet 25, unlike some other aircraft, you'll find it mounted prominently on the forward fuselage near the nose. It's essentially a small, freely pivoting airfoil, or a flat plate, designed to align itself with the local airflow. As the angle between the wing and the incoming air changes, the angle of attack, the vane pivots up or down to reflect this change in airflow direction. This mechanical movement is then translated into an electrical signal. The angle of attack vane is directly exposed to the airflow at the nose. As the aircraft's pitch attitude, or the direction of the relative wind shifts, the vane aligns itself with the new airflow direction. This pivoting motion is linked to a sensor, often a potentiometer or a resolver, housed within the vane's mounting assembly. This sensor converts the mechanical angle of the vane into an electrical signal that is proportional to the angle of attack. This electrical signal is then sent to various aircraft systems, most importantly the stall warning system, and sometimes an angle of attack indicator in the cockpit. The pilot receives a warning, typically a stick shaker or an audible alert, when the critical AOA, the point where the wing will start to stall, is approached. The angle of attack vane plays a vital role in flight safety by providing crucial information about the aircraft's proximity to a stall. A stall occurs when the airflow over the wing becomes separated, resulting in a significant loss of lift. Sensing the angle of attack, the vane and its associated systems help pilots avoid stalls by providing early warning before a critical AOA is reached, allowing the pilot to take corrective action, like lowering the nose or increasing airspeed. Optimize performance, since in some aircraft, AOA information can help pilots fly at the most efficient angles of attack for certain phases of flight. Accurate AOA information is especially critical during low-speed operations, like takeoff and landing, and during maneuvers. A malfunctioning or damaged AOA vane can lead to unreliable or absent stall warnings, significantly increasing the risk of a stall. Now, let's look at the basic maintenance and inspection procedures for the angle of attack vane, right here on the Learjet 25's nose. A primary check involves ensuring the vane can move freely. Gently try to pivot the vane by hand. It should move smoothly, without any binding, stiffness, or excessive resistance. Any restriction in movement can indicate a problem with the vane or its internal mechanism. Visually inspect the vane itself for any physical damage, such as bends, cracks, dents, or corrosion. Even minor damage can affect its aerodynamic properties and accuracy. Also, check the mounting of the vane to the fuselage. Ensure it is secure and that there are no loose fasteners or signs of damage to the mounting structure. Pay attention to any signs of obstructions around the vane, such as paint buildup or debris. Keep the area around the vane clean. If any issues are found, like restricted movement or physical damage, it's crucial to report it to a certified mechanic for further inspection and repair. Do not attempt to force the vane if it's stuck. That concludes our look at the angle of attack vane and its importance in providing crucial stall margin awareness on the Learjet 25. This seemingly small sensor located right on the nose is a critical link in the chain of flight safety. Be sure to scan the QR code for additional learning materials. We'll see you in the next video.